Hi, hello everyone, it's Praveen, and today in this video we're gonna discuss about Geeks for Geeks problem of the day. Today's date is 13th of August 2025. Before diving into the session, I request you to subscribe my YouTube channel because I upload GFG problem of the day on regular basis. Not only the code, my primary purpose is to reveal the logic and intuition behind it. Okay, let's without further wasting any time, let's dive into the session. Today's question is twin war strategy, and it's a array based question. uh, it's classified as a difficult or easy difficulty level question. Yes, it's pretty easy, but you have to understand the logic. Let me read the question. You are given an array A or R of size n, where A or R of I represents the number of soldiers in the troop, in the ith troop. You are also given an integer k, a troop considered lucky. The number of soldiers is a multiple of k. Find the minimum total number of soldiers to add across all troops so that at least n by 2 troops become lucky. Let us try to break it down one by one. We are given an array which name is A or R, and its size is n, and it contains a set of troops, and each troop, I mean every ith troop represents a troop, and it may have n number of soldiers. It really it changes. It's not a static one. For example, here in this array you can see 1, 2, 3, 4, 5. This array's size is 5, and we do have a different types of troop. For example, in this troop we have 5 soldiers only. In this troop I have 6 soldiers. In this troop I have 3 soldiers. In this one I have 2, and this one I have 1 soldiers. Our goal is to win a war. We need at least at least we need n by 2 troops, and it's not directly n by 2. We have to make few observations because this array's length is 6. You can see here 6 divided by 2, which is equal to 3, which is exactly, just a minute, the arrays for the TC2, for the test case 2, the array's length is 6 divided by 2 equal to exactly 3, which is greater than or equal to n by 2. That's fine. Okay, Praveen. What if the array's length is odd? That's a great question. Let me answer it. Let me write it down on top of this TC. TC1, test case 1. Eventually, before writing that, I would like to show an example. We don't have to necessarily think n by 2 always mean n uh, divided by 2. Like, it's not exactly like n by 2. It's not the same thing, because in Python for this your value would be 2.5. In Java, that is, if it is odd, assume the length is 5, then we get only 2, a integer value, not a float value, since we doesn't necessarily perform a float division. Okay, assume n is equal to 9, not 5. Just basically it's a odd number, not even. Okay, in this test case I have to find the n by 2 troops, which, for if we use Java, 9 by 2 turns to be 4, but actually it's not. It is not equal to 9 by 2.0. Basically, I try to mean whenever the array's length is odd, it necessarily both are not equal. 4 not equal to 4.5 since it's a odd number. So what we have to do is we need exactly this one minimum, exactly this one. For sure we need it minimum. It might go beyond that, but we should also avoid that. So what I'm going to do is, we know practically it's impossible to achieve this number since we are dealing with whole numbers element from the array. So I instead I instead change my value to 5. 4 plus 1 equal to 5, which is greater than or equal to 4.5. Yes, true. As well as this could be the lowest value as possible for your array with odd length. I hope you could get my point. So whenever the array's length is odd, we have to increase our required troops target by 1. We have to add 1. With that I mean, in this TC2 our target is to ensure three at least three troops are lucky. And for the first test case, here we try to mean we at least, I once again repeat, we at least need 5 troops to win that war. 5 lucky troops, I'm so sorry. Uh, 5 lucky troops to win the war. If it is even now, it's so simple. We just divide it by 2 and we have to achieve the target. But if it is odd now, we have to be careful and add 1. We have to increase the value by 1. So simple. I hope you understand this point. I think I forgot. Let's move to the next point. We are given an array 5, 6, 3, 2, 1. That's pretty good. And we have to find the number of lucky troops. Is 5 divisible by 2? No. In order to change it to a number that is divisible by 2, we can either increase or decrease it. But in this question it's clearly mentioned we are only allowed to increase the value, not decrease. So I simply say, if I add 1 to this element, it becomes 6, which is divisible by 2. While considering the next element 6, 6 itself is divisible by 2, so they are lucky troop. And let's move to the next one, that is 3. Okay, is 3 divisible by 2? No. So how to convert it to an integer so that it is divisible by k? Now we have to add 1. We have to increase the k's value by 1 so that it turns to be 4, which is divisible by 2. Let's move to the next one. 2. 2 itself is divisible by k. That's pretty good. And I move to the next one, that is 1. Is 1 divisible by 2? No. So how to convert it to a number that is actually divisible by 2? We have to increase the value by 1 here. So with this in your mind, you can build a map to relate all these things. Like for this one, if you increase the value by 1, it turns into a number which is divisible by k. This one, there is no need, itself divisible by k. For this one, we also need to just give me a second. Let me write it down on this whiteboard so that you get better clarity. 5, 6, 3, 2, 1. 5, 6, 3, 2, 1. That's good. I say for this one, for this one, for this one, I have to increase the value by 1 so that it turns into a number which is divisible by k. Here we know the k's value is 2. The k value might change. We have to be careful with that one. It's dynamic. And I can also state that 6 and 2 are already divisible by 2. It's already divisible. Hey Praveen, I am slowly getting your point, but how to technically implement it on coding? We will dive into that part later. Just try to understand the question. That's the art. If you master it now, then coding will be pretty easier for you. Let me clarify you with one more test case. Look at this one. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. It is the array and its length is 5, 6, 7, 8, 9, 10, 6, which is a even number. So no need to equal to 0. So our target is 3. We need at least 3 troops to win that particular war. 3 lucky troops. So I check this one. Here the k, sorry, I'm so sorry. I forgot to write down the k's value. That is most important. Here in this test case, you can see the k's value equal to 4. K's value equal to 4. K's, the k's value equal to 4. Okay, that's simple. Here I can say, is 5 divisible by 4? No, we have a remainder of 1, which indicates not divisible by 4. So how to convert it to an integer that is actually divisible by 4? It's 5. I add 3 with that number, so it turns out into 8 that is actually divisible by k. So it requires 3 to convert it into a number that is divisible by 4. It requires 3, it points here, and I check this one, it requires 2, this point here, it requires 1, it points here, it doesn't need anything, so it points 0, and it requires 3, so it points here, and it requires 2, so that it points here. That's it. Once again, let me write it. For the zeroth value, we don't have to make any changes, and the array, the numbers which satisfy that condition are 8. 8 only. It's only 8. Okay, let's move to the next one. That is 1. For 1, we have only 7. Let's dive into the next. For 2, we have 5 comma 9. For 3, I think I made a mistake. Just for 2, it indicates 6 comma 10. For 3, it points out 5 comma 9. So that's it. I hope you are familiar with structure. Yes, it's HashMap in Java and in Python. it's actually map. That's it. So 0 points a list that only contains element 8, which itself is divisible. We don't have to bother about anything. And for 1, we have only one element, that is 7. For 2, 3, we have two elements for each of them respectively. Okay. So if you understand till this point now, that's it. We are good to write. We are good to go with the technical part. We may write the code. Once again, I'm trying to clarify the question. You are given an array, and its size should be either odd or even, and it consists of troops. Troops means a set of soldiers. Example, in a war, a troop. This is a point. It's actually a country. It's actually a country. This troop consists of 8 members, and here this troop consists of 10 members, and this troop consists of 3 members. This is actually a troop. Troop means it consists 3 soldiers, it consists 10 soldiers, and it consists 8 soldiers. So we are given a troops, and we are given a number k equal to 4. To win that war, we need at least, for sure, at least we need n divisible by 2 troops, so that we could win that war. And those troops which are divisible by k is known as lucky troops. So we check this one itself. The number itself is divisible by 4, so we don't have to make any changes. I am straight away putting it into a list, a array list, and I check this one. For this one, I need exactly one element, so that it turns into a number which is divisible by 4. So wait, I add it into a list. For this one, I need 2. Simple as it sounds. Okay, let's move to the implementation part. I hope you understood. Okay, I'm creating a hash map for this one, and a tree map, a tree set, as well as it contains the keys, because we have to sort the keys in order to find the numbers with with minimal requirements. For example, uh, okay, in this array, okay, okay. For example, in this array, we are already 2 as well as 6 satisfies the condition, but here the array's length is 5, which is your odd number. So 5 by 2, that is 2 as an integer value, not as a whole value something. So we have to increase it by 1, so it turns into 3. But we have only 2 lucky troops, so I have to increase a number of soldiers in any troop so that it becomes a lucky troop. I check this one, 5, 1. I check this one, if I add 1 now, it becomes like a troop. I check this one, if I add now, it becomes like a troop. It's so simple. But in this test case, you have to carefully observe we need exactly 3. So I check this one. None of the element satisfies the given condition. None of the number is divisible by 4. So we have to pick 3 elements. So I try to choose whatever the number requires minimum cost or minimum soldiers to make it into a number that is divisible by 4. I mean divisible by k. So I check this one. It requires only 1. So I take this one, and then I check that is nothing else which could be turned into a number that is divisible by 4 with only adding 1 by 1 by adding only 1. It's not possible here. So I move to the next thing, that is 6. 6 plus 1 equal to 6 plus 2 equal to 8, that is divisible by 2. Pretty good. So far we use the 6 and 7, and let me move to the 10 as well as 10. Or no, we can convert this one also into 4 by adding 1. So 3 plus 1 equal to 4, 7 plus 1 equal to 8. So far we made 2 lucky troops. So I need only one more. For that I'm choosing this one because it requires only two soldiers. While comparing this one, it takes 3 soldiers to become a lucky troop, and this one cost me only 2 soldiers. So I prefer this one. This one cost me 3 soldiers, as well as this one cost me 2 soldiers. I can choose anyone in between among this one or this one. Both of them cost me 2 soldiers. I choose something. It doesn't even matter. So I choose 6. So what I'm going to do, implement it technically. I created a hash map and I created a tree set to track the keys as well as to keep it sorted. And until and indicates the array's length. I am taking each the element from a array, the array called ARR. If key, I mean k means uh, k means the given number. If k minus I modulo k. For example, 5 modulo k. 5 modulo 2 is 1. I think we should try to avoid the first mistake since it is so simple. If you only focus this now, you would be getting so many errors. So let's move to the next one. This one for 3, 3 divisible by 4, that is 3 itself. So I get 3 and my k minus 3 equal to 1. So I need only one element to convert it into a number that is divisible by k. For 5, I just check it. 5 divisible by 4, that is 1. So 4 minus 1, that is 3. Simple. Here I means the number. So 5 modulo k means the 4. And again we are applying the k to figure out the number of soldiers required. If k equal to k now, it rarely happens when the number itself satisfies the condition. For example, here assume a number like 8 or 12, something like that. If we divide 8 by 4, if we divide 8 by 4 using the modulo operator, then the answer is 0. So 4 minus 0 equal to 4. So if k equal to k now, we have to update the key as 0 since it requires nothing, just 0. And in this part I'm checking the hash set, sorry, the tree set called key contains the particular key or not. If it contains now, I'm just adding the respective value of that of the element to that array list. If it doesn't exist, in case it doesn't exist, I create a new array list. Here I'm using LinkedList, and I'm so sorry, I just add that particular element and I push it back into my hash map. In Java we use put method, and at last I'm adding the key to the tree set called keys. Okay, that's it. With this we created a hash map which key is basically the number of soldiers required to convert a number into a number that is actually divisible by k. A number that indicates, that refers, that points a array list. In that array list, I mean in that list, we do have a set of numbers which either divisible by k or it requires n number of soldiers to make it a number divisible by k. In troops, in the int troops, I'm just trying to figure out. Let's move to the next part. In this part, we're gonna discover how many troops required to make it happen. I'm initially assuming the troops value equal to 0 and required equal to ln by 2. Okay, either it's even or odd, for sure we need ln by 2, but in a special case, if the length is odd now, we have to increase it by 1. That's what I'm doing here. I have already explained you this part earlier in this video thoroughly, so let me move to the next part. I'm taking each the element from keys, and if required not equal to 0 now, I'm just it most probably won't happen. Uh, Sorry, in the earlier time it won't happen. If require not equal to 0, I'm trying to figure out int current equal to math.min of required, comma, track dot get of I dot size. Here, this one goes like what are the element which actually need it starts with 0 and moves to 1. Here 0 means it requires nothing. So we directly count those values. And let's move to the next one if available, or move to the next one. If 2 is not available, the next smallest element. That is if 4 or 5, it moves to the 5. If it is available, if it is not, then it moves to the next element, which is the smallest. It continues. This loop continues until we until the required troops becomes 0. If with the math.min I'm comparing the required soldiers, required troops with the size of the troop current troop set. So the minimum value is subtracted from the required, as well as the same value is multiplied with I, so that I figure out the number of troops required. As long as the required not equal to 0, we are doing this operation. Once it hits that point, then we return the troops and exit from the program. If it in this case, as per the constraints, we should return the troops. And if it is not possible now, we exit with a value of 0. Here you can see. That's it. Thanks for watching my video. I hope you helped today with my solution. Let me catch you tomorrow. Until then, signing off. Praveen. Bye.